The Standard Model is our theory of particle physics. It is our best explanation for what the universe is made of at these really tiny scales, what sticks these things together, why they behave like they do. Our whole knowledge is encapsulated in the equations of this theory. And this theory is really, really good. It's so distressingly good that it predicts everything pretty much that we've seen in our experiments. And that's why we call it the Standard Model, because it really is the standard explanation for why the universe is like it is.
The Standard Model of the universe is so important that CERN have even put it on a coffee cup. I'm not going to pretend to understand it, but this equation tells us everything we need to know about the interactions of subatomic particles in our universe as we understand them at present. But even this model has a couple of problems.
The Standard Model really does have problems, and it sounds stupid to say that when it's such a successful theory. But the problem is that we know it's not the whole answer. We know it's not the whole explanation of everything in the universe. We know there's stuff out there that just cannot be either contained in this theory or explained by it. And I'm talking about things like dark matter, this mysterious, elusive, invisible stuff out in the universe that's responsible for making stars rotate around galaxies in the way they do, but which we don't know what this stuff is. And our theory certainly doesn't predict it or explain it. Our theory doesn't even include gravity. And that is a huge oversight because we know that gravity exists. It's why I'm sitting on a bench. It's why I'm not out in space. And yet our theory cannot put gravity in the same equations that it can express the other forces in. It's really good, but it's an effective theory. It's not the whole answer. A really fundamental explanation would include gravity, would explain dark matter, would explain antimatter, and anything else in the universe as well.